Welcome, everyone. My name is Clark Jarvis. I'm a software product marketer from Infineon, and one of the products that I'm responsible for is Modus Toolbox and its use inside of doing machine learning. So let me go ahead and share my screen. Uh, we'll get some of the presentation details up. The approach or the things that I want to cover in this presentation is I first want to give kind of an overview of what edge AI is, right? We hear a lot about AI, about machine learning, and we'll talk specifically about some of the specific details around what it takes to create a machine learning application or what it takes to do edge AI. So go through some of the basic concepts, and then we'll break that down into a couple of different areas. So we'll talk specifically about doing data collection, right? How do I get data into the system? How do I then create the model, right? Do the training and the processing that's involved in that. And then actually doing the deployment, taking that resulting model and go doing something cool with it. As Jesselyn mentioned as well, right? There is the Hackster.io design contest that's being sponsored by Infineon. So a lot of the content here is really geared around some of that content. And we'll talk specifically about some of the aspects around the ready models, so the deep craft ready models, as well as the streaming firmware and other code examples that are available for the PSOC 6 AI kit that are really geared towards the submissions for this Hackster.io contest. So with that, let's get into some of the details here. First, kind of basic concepts of what Edge AI development flow is. And there's a lot involved here. And we only have an hour, so we're going to hit like highlights of these as we go throughout the details and kind of the demonstration of them. But if you want more information on these specific items, one of the links or one of the resources that is available is the ImagineMob developer portal. So in this outline actually came directly from that. So there are specific sections and chapters inside of that developer portal. They go into a lot more detail about these specific areas as it relates to Edge AI. So first we'll talk about data preparation, right? So this is everything needed to collect the data, to be able to have a device or something that's reading information off of a sensor, and I'm feeding that into, in this case, the DeepCraft Studio application. So then I have this wealth of data, right? And at this point, it's just data points, right? Whether it's graphs that show like an XYZ coordinates for accelerometer, or it's audio data from a microphone. And my next step is actually start going in and labeling it, right? This is what occurred at that particular data point, right? So I know this is in a particular event, and that's critical to then feeding into the machine learning algorithms and engines. I also do some distribution, right? There's various types of data. I'll have data that I use to actually do training, and I'll use data that I use to do testing, right? Is there a separate set of data that I feed through the model, and do I get the results that I expect, as well as doing data around validation? So various use cases. And so you want to make sure you have enough data, it's properly distributed into these categories so that you can then go create the correct model. There's pre-processing that can be done as well. And this has to do with, right, how big of a chunk of data am I looking at a particular time? How fast is the data coming into my system? And other processing filtering, right? Am I doing some type of an FFT transform on it or some kind of normalization or gain function? A lot of capabilities that may need to be done so that I can manipulate the data or somehow massage it into a format that is more conducive to my particular use case, right? Maybe I'm looking for a very specific frequency, and so I optimize an FFT transform on it to really highlight or excel or accentuate that particular frequency range. Once we're at a point where we're saying, hey, I'm satisfied with the look and the feel of the data, I think it's going to meet my use case, and it's all labeled, we're ready to start doing the model training. So one is actual generations of the models. So we'll look through some of the examples that exist inside of the DeepCraft Studio application for generating the models, some parameters that we have access to be able to tweak those, and trying to do this at a high level and let some of the intelligence that's in the tool, the auto ML capabilities, kind of figure out a lot of these pieces for me, and then submit that job to the cloud so I can take advantage of parallel cloud processing, right? The heavy lifting to actually go and turn these models into something that's usable. So once I have a model that has been trained, I've got something that exists that is usable. How good is it? How does it work? And I can start looking at the performance of it, right, and doing some evaluation of this model and maybe iterate. Right, I need to go collect more data, or I need to tweak the processing a little bit more for my use case. But there's various performance metrics that come out of the tool. There's a confusion matrix, right, which shows like how well for the particular item or event that I'm trying to detect, how likely is it to be corrected or detected correctly, both from a false positive or a negative type results. And I actually can even then take data and feed live data in from my device and see how it compares with that model as well. And this is all geared around making sure that I have a model that I'm happy with, that's going to work like I want it to. Next step is then starting to look at like, okay, how do I get this on a edge device, right? How do I get this on a small microcontroller? So there's the code generation aspect where I can optimize for my device, right? Do I need to quantize it to, instead of a big floating point, do I have a floating point unit on the device I can take advantage of? Am I okay with using 8-bit quantization, or do I need to stick with float values? All of the pre-processing that we set up in the earlier sections, right? Generating the C code to be able to do that on the embedded device. And at the end of the day, what I'm needing is actual source code. And so that's where I can generate source code that I can then take and put into my embedded application. And that's what feeds us into the deployment side. So this is where I'm focused on an embedded application. So I'm working with a project. I've got different APIs, whether they're machine learning middleware APIs, or maybe I'm using some communication APIs, other things that even exist outside of the machine learning use case and the edge AI use case, but connecting it to the rest of the world, right? Am I connecting it to some type of a cloud service? Am I sending out an MQTT message, or am I just maybe controlling GPIOs, things like that? And then one of the key functions or key APIs that we'll talk about as well as it relates to the machine learning is then the queue API. So this is the ability to start queuing in data into the model itself. And then once I have a sufficient amount of data, I'm able to then dequeue that or pull it out of the queue with some type of a inference or decision that's made on that. So a lot is involved, right? Again, to kind of summarize that, these are kind of the main concepts. And then as well as to reiterate a lot more detail about these specific steps and areas that relate to Edge AI can be found at the developer portal on developer.imaginemob.com. So let's get into some of the specifics of that, right? It'll be a lot of those same concepts. We're now going to start applying them to the specific tools that we have available from Infineon, the tools and the specific details that are also a key part of the contest that this is related to. So we'll talk about data collection and labeling. So first thing I'll do is I'm going to start with the PSOC 6 evaluation kit. You will see that there are two different USB ports on it, and it will be critical to understand which one is which, right? The top one here is the one that's using USB to the target. So it's kind of our main data pipe. It's how we're passing out data today to be able to feed into the DeepCraft Studio. And so first step here, you can kind of see in the image here, and we'll see this in the live demo, but I'm able to set up this device or reflect this device inside of the Graph UX screen, where I can say, I want to collect some of the data from the magnetometer. So I'll bring that in as an object. Do I need to do any filtering or modifications to it? I can set up those different units, those different blocks that are available from this node library that we can kind of see here in the background. And then start visualizing that, right? Feed it into an actual data view where I can start recording the data. So once I record the data, you'll see a view that's similar to this, right? We get a lot of data that is coming in, and it's a timeline of data. And I will have different events or kind of markers that say, okay, this is where this particular thing happened, or maybe I'm recording one particular event over and over. There's various strategies around collecting the data, but ultimately I need to go back into that data and start labeling it. So there'll be an additional track that's down kind of on the lower section where I can say, okay, this little time slice of what was occurring here is this particular event. And you can see an example of that where this went from kind of a standing label to a running label. So this was using an accelerometer with the subject running, and this is kind of the profile of what that looked like. And so this gets labeled as running. And so you go through that, you will see examples of that with some of the starter projects available in Studio, where we'll have a large collection of data that are labeled. Okay, so we've done the data collection, the processing, we've got it labeled, we're ready to create our model. And there's a couple of pieces, right? Here's kind of the flow as it relates to this. Our first step would be to actually generate a model list. So there are a variety of ways to do this inside of Studio. Certainly the easiest is going to use the Auto ML feature, which just gives you a couple of parameters that we're going to specify, right? Do I need this to be a small model, or I'm okay with it being a larger model, right? And that's going to impact performance. Do I want to optimize on speed, right? So the inference times are lower. I'm able to make decisions very quick. Or am I more concerned with accuracy? I'm okay with taking a little bit longer because I really need those results to be more precise. So these are the types of decisions we can make. And the result of that is going to be a selection, or a set of, I think it's like 4 models by default, right? There's going to be a selection of models that I can then submit to the cloud services to actually do the training on. So that's where it's then going to provide all of the data. It'll upload data to cloud service and process that in the background. So at that point, you can go off and do something else and let it, process, and then get a notification of when that's complete. Once that training has been completed, right, there'll be some type of a notification where I can say, okay, this data is available. You have a model now. We'll have like a .h5 file, which is one of the formats that's used to store large amounts of data. And I can download that back into the Studio application and have now a view that kind of shows me some of the aspects of the model itself. And I start going into that analyze performance. And really one of the most beneficial views that I see is the view here where it says number 4. This is the confusion matrix. And this is giving you a good indication of, if I receive an event, right, I'm predicted to have detected the audio down. How likely am I to actually make that decision based on the test data, based on the data that I sent it? And so you can optimize it, right? You can see, like in this case, right? Well, maybe when it's silent, or have background noise, it kind of feels like there's a few times where it's doing a false detection on down in this case. So maybe I need to go collect some more data around down, or do some better processing on the audio signal that's coming in, so it's a little bit of detection. So I can make decisions, and I may be like, hey, 94%, that works for me, right? That's going to be great. That is a pretty good value. So this is the type of decisions you can make to say, okay, this model is valid, or no, I need to maybe adjust some of these parameters. Maybe that accuracy up here in the Auto ML, I'll go ahead and bump it up at the cost of a slightly longer inference time to be able to have a model that meets my use case. So we've got a model at this point, right? It's been trained. We've got it inside of Studio. We're able to validate that it does meet our needs. And now we need to get it onto our device. We need to deploy it. So there is a view inside of DeepCraft Studio that's shown here, where I've actually selected the .h5 file, the one that corresponds to the model that I like, right? Maybe this is the one that had the fewest number of parameters, but still met the validation or the quality that I wanted. And I'm going to generate C code for that. So there's a selection here inside of the code generation where I'll specify I'm going to generate this for the Infineon PSOC device, specifically the PSOC 6. And that's the one that we're highlighting here with the PSOC 6 AI kit. And then I can define, right, where do I want it to go, right? I can actually even browse and have it generate the files so that they go directly into my project if I know where that exists, or just generate them there on the file system, and I can cut and paste them into my application. And then we actually have the prefix, right? What are the file names? And so if you can see, I know it's probably a little bit of small text on the screen here, but this has generated a model.c and a model.h file that's going to have all of the pre-processing that I implemented inside of the Studio application. It's going to have all the APIs to initialize my model, to be able to start enqueuing data into the model, right? So I'm passing it in kind of like data point at a time. And once that aligns to the filtering windows, right, the sizes, the sliding window that I define inside of Studio, it'll then make a decision on that. And so then I can use what's referred to as the DQ API to then detect, right, was there something detected? And I'm developing that now. We're showing an example here of using Modus Toolbox with the VS Code IDE to bring that generated code into a project. I can start adding in other business logic, like what do I want to do with the decision? And then I can program that to my device and actually see how it functions. So that's kind of those are the kind of the main applications that we'll talk about as we go throughout the rest of this webinar, and kind of the main flow that we'll use, right? So we start with the board itself. Going back a little bit, we start with the board. We use that to do data collection. We live inside of Studio a little bit, iterating through the training, iterating through collecting more data, generating the models, validating that it meets our performance, and then building that into an application. So those are the main concepts. So now what I want to do is we'll shift gears a little bit and start talking more about, okay, how do I get started, right? How do I actually go about doing this? So I want to start with the development kit itself, right? So we have the PSOC 6 AI eval kit. So really cool little board. Got a lot of, small form factor, got a lot of sensors and different things packed into it, as well as different headers, right? So you can actually expand this, connect it to other things. So a couple of key items that I want to highlight, and at the end of this presentation, especially if you download the PDF version of the presentation, there are links at the end for all of these resources. First one I'll highlight is the Getting Started Guide. A couple of key things that are in this Getting Started Guide are details on updating the firmware. So there is, I'll be referring to this firmware quite a bit throughout this presentation. There is a streaming firmware. So this is firmware that runs on the board. It's fully enabled to connect directly to DeepCraft Studio and enable the data collection. So that's one of the key things about this firmware. And so it's able to use the accelerometer, the magnetometer, gyroscope, pressure sensor, and radar. And the other step that is detailed in this Getting Started Guide is then the steps to do data collection. So that step that we talked about a few screens ago, where I'm feeding data into DeepCraft Studio. How do I set up the GraphUX? We'll look a little bit at this in the last half of this webinar. But if you want a more detailed, right, follow these steps to get something up and running, Getting Started Guide is a good resource. Now, when you need more details, there is also a user guide. So if you're looking for things on what's the exact pinout, right? So you see a preview of some of that data here in the lower right, but I want to connect it. I want to connect up a GPIO or an I2C something, right? I want to start attaching things to this board. You'll have all the details in terms of the pinouts of the board features, right? The different buttons that are available on the board, the different connectors, things like that. The user guide will also walk you through creating a Modus Toolbox project as well. So kind of a out-of-box getting started with Modus Toolbox. I think it may be a simple like Hello World type application, but you can bring in a variety of different projects that we have for this board to understand how the board works and start using that to build up larger applications. The user guide also has details on the schematic. So inside of the user guide, there'll be snapshots of the schematic for different areas of the board. You can also download a specific schematic or design files as a separate download as well on the page for the PSOC 6 AI kit. The few features of the board itself, it is based on a PSOC 6.2 MCU. This is running at 150 megahertz, has 2 meg flash and 1 meg of SRAM. There is connectivity on the board. So this is done using an AROC CYW 43439 board. This includes both Wi-Fi and Bluetooth. And then there will be example projects inside of Modus Toolbox on using the connectivity. It does have an onboard debugger, so you're able to connect directly to the USB through the bottom USB connector here and able to program the device directly through USB. And I think we've mentioned a couple times the sensors. There is a digital microphone, a PDM, PCM digital microphone, a six-axis motion sensor, magnetometer, barometric pressure sensor that also has some temperature data on it, and then a radar sensor. So a lot of cool stuff all packed into a small board. One of the things you can do with this board, if you don't want to go down the whole path of like installing all the tools just yet, we do have a web evaluation. So you can do it. It's an online developer experience at devkit.infineon.com, and it enables web programming. So you just connect the board through USB, and you're able to download some of the code examples, and these are centered around the Edge AI models that are applicable to this particular webinar. And there's an interactive console, so as I'm playing different audio clips or doing the hand gestures, they're able to see those, the output of those in the web page. So the main thing here is you can very easily program and test a variety of AI models. So there are ones that are based around radar, so doing whether it's present detection, so is somebody in the room? Are they moving? Are they doing small motions or large motions of like entering or exiting a room? As well as gesture detections, which is showing an image of that where it actually does swipe detection and press detection. There are audio examples using the digital microphone. These things like detection of a baby crying, a cough, a siren, factory alarm, and snoring are examples that are built into this. The other cool thing is, we've talked a lot about this streaming firmware, and there are steps to update that firmware. Well, this web experience is actually one of the places you can update that firmware very quickly. Just log into it, you connect your board, select the program button, and it will flash the board with the latest for streaming firmware. So it's always a way, if you need to come back to it, easy way to do that. Now, there are some specific prerequisites. There are steps you need to do to prepare the board, to enable the board to work on this. These steps are all kind of pictorialized in a little guide on the web page, so it should be easy to follow. But ultimately, you are needing to update the KitProg firmware. So this is the firmware that's running on the little debug portion of the board. And then there's a button on the back of the board to actually put it in the correct mode. And the web page will guide you through all of that. So again, a cool thing you can use to at least test out some of these AI models, see what they do, and see if you want to use them in your application. But eventually, right, we need to get to the real development, right? We need to get to the real tools. We need to start doing some actual development and installing applications on our computer. So the main ones we're going to talk about here, we've got DeepCraft Studio. This is an Edge AI development tool that's covering the data preparation, model creation, and code generation. This is available for download from the Infineon Developer Center and from imagimob.com. It does require an account registration on imagimob.com. Maybe a quick note, imagimob.com is an Infineon Technologies company, but it does right now have a different web page, and so you do have to create an account to be able to access the tool and to do the cloud-based training. Then there's Modus Toolbox. So Modus Toolbox is going to be the main development build environment that you'll use to do the embedded side of it, right? So whether it's some of the data collection stuff or most prevalent on the deployment side, right? Creating the code around that. It is also available from the Infineon Developer Center. It does require an account registration on Infineon.com. And you'll install this using a Modus Toolbox setup program. So that's actually what you're downloading, installing as a setup program. And then that setup program will help work through, right, getting the right base tools package installed. If you're wanting to use the Eclipse IDE, it'll help get that installed, or you can just select to download or access VS Code. And then what tool chain, right? So things like the Eclipse IDE, VS Code, GCC toolchain, those are probably the most common options that you'll select when doing the Modus Toolbox installation. And through that, you're going to find a variety of applications, code examples. We refer to them as using the Modus Toolbox project creator. that'll generate projects directly for the Eclipse IDE or VS Code, or if you have a license and are working with IAR's Embedded Workbench or Kyle MDK with the Microvision IDE, those are all supported as well. And again, to reiterate, right, I think we've mentioned several times, you do need the latest PSOC 6 AI Kit streaming firmware. This is a pre-compiled firmware that supports the data collection into DeepCraft Studio. So 2 resources that you have. We do have the Getting Started guide that we talked about on the previous screen, as well as a firmware update tutorial. So this is a quick little video that you can watch, and it'll walk you through the process of getting that updated. All right, so now let's talk about some of the actual pieces, right? The resources that I'll use when creating these examples, and there's three that I want to highlight, or 3 areas I want to highlight. The first is around ready models. So what a ready model is it is a production ready edge AI model that is available as a pre-compiled demo image. So you can actually go to like imagemob.com or that web experience, and you can download this pre-compiled demo, right? And so you actually see how it functions and test out kind of the quality of that particular AI model. In addition to it being pre-compiled, right? It's just a canned experience, right? It just prints out, what it does. These are also available, or some of them are also available as evaluation binaries. So libraries.a files that can be used inside of a project. And this is particularly important for the design contest, because we have a specific category of submissions that are centered around using these ready models. So I can pick up one of these ready models, whether it's an audio-based one, doing things like baby cry, cough, siren, factory alarm, and snoring, or doing a radar-based one, which is the hand gesture detection, so swiping left, right, up, down, and a press. You don't really have control over adding more data or changing how the model works. The model is as it is. But what you do have access to is being able to adjust what the outcome, right? What I do with the result. And so there's code examples that we talk about. So it's the DeepCraft, that's what's here. Next bullet point is the DeepCraft ready model deployment for PSOC 6 MCU. So this is the code example. It's available inside of the Modus Toolbox project creator for this particular board. And it actually has some compiler options. I'll highlight those in the live demo here to be able to switch. So it's just one code example, and you're able to change the mode that it works based on which one of these evaluation binary libraries you want to compile into the project. So details about switching that is all available in the README for that project. But an easy way to say, I'm not gonna worry about collecting additional data, right? One of these use cases meets my need. I want to focus on the business logic, right? What do I do with the result, and doing something cool with it on the deployment side. Kind of somewhere in the middle, then we'll talk about the DeepCraft starter models. So kind of similar to the ready models, everything's kind of done for you, or at least there's a starting point for you. And these are reference AI models. So it's a starting model. It comes as a complete DeepCraft Studio project. So when I open up the project, and we'll show some of these, I have all of the data that was used to collect or to train that model. It's all labeled for me, so I kind of see how the labeling happens. If there was any processing that was done, we get an example of what type of processing is typically added to an audio-based project, right? So I can see where they did some of the smoothing and filtering, things like that. So it's a good reference to use for these different use cases. There are starter models available that cover audio, motion, and touch. You'll see a lot of the similar ones that we've highlighted before, but on the audio side, we'll have things like a baby cry, gunshot detection, chainsaw detection, home sounds, which will be things like, I think baby cry is also included in that, as well as like maybe a water drip sound, or different types of alarms. Drill material, so what type of material am I drilling into based on an audio, siren detection, and then keyword. And keyword is one that has a couple of kind of common phrases that come out of a particular kind of available model, the industry standard model. Motion side, so this is using accelerometer. There are reference projects for things like fall detection, human activities. So this is like running, standing up, things sitting still, things like that. Again, another drill material, but this one using the motion, right? So when when the drill goes through a particular material, we're able to detect that. Fan anomaly, right? I have a fan running, a little kind of motor, right? But is it changing? Is something happening? Is it vibrating in a way that I was not expecting? And then an example around touch, right? So using our capacitive touch CapSense to do touch detection through an AI model as well. Now, when it comes to using those applications, right? So I can open them up in DeepCraft Studio. I can see how they were trained, to see how they were labeled, see how the data was collected. I also have options for deploying them as well. And there are DeepCraft Studio deploy model code examples. And there are two examples here, one for audio and one for motion. And these are available inside of the Modus Toolbox project creator. And what they will come with one of the models already set up, ready to go. So you just bring the project in, hit compile, and you can flash it to the board. And I don't recall exactly which one, but there will be a particular model that's the default model. What I can do, right, is I can then come back into DeepCraft Studio, open up one of these starter projects, and I can go through the exercise. I don't need to collect any more data or train more data, but I can do code generation. So I can actually generate that model.c, model.h file from this starter project and drop that into my application. So there's an audio-based one and a motion-based one. So I should be able to take any of these reference projects, generate the code, and then be able to use that same data collection, right? The same audio data, feed it into a different model, and now be able to detect one of these other use cases. So again, another nice feature, right? Maybe you use it as a starting point for your particular application, or just as a learning experience to see the amount of data that was collected, how the data was distributed across the different test and training and validation data sets, and what parameters were used to generate the model itself. So good resource to be able to use. Ultimately, with this flow, right, you're going to be working inside of DeepCraft Studio to update a model, bring that into the IDE. In this case, we're showing the Eclipse-based IDE, and be able to add in the additional logic, right? What do I want to do now with the result of this? Something more exciting than just doing a printf, and then get that onto my application. Then the last one I want to talk about is then kind of like, all right, let's go all in, right? What do we need to do if I have a completely novel idea? I want to start from kind of a blank slate and go through the whole process of collecting unique data, creating a model around that, and then deploying it to my application. And this is really one of the kind of the goals of the contest that we have, is right to see what types of use cases and what types of models can this community create. So a couple of the key resources that are going to be used in this particular flow is first going back to that DeepCraft streaming protocol. So that protocol is designed specifically to work with the Graph UX feature that is in Studio. The streaming protocol itself is the piece that is going to enable all of the sensor collection from the PSOC 6 AI kit's onboard sensors. It's going to feed that into Studio, where I can then take advantage of the Graph UX, which is a really nice layout, right? It gives me basically a blank page, graphical page. I can bring in a graphical node that represents the device. I can run the output of that through some different filtering that I need, right? Or maybe I want to do a spectrometer on some audio data, or some type of a gain adjustment. And I can actually then visualize the data that comes out of that and start collecting the data. So that'll be the key thing to get started, right? First, data collection. Do that through the streaming protocol and the Graph UX. Once that data is inside of Studio, what we kind of covered on the other slides previously, right? Then I actually need to go create the model, right? So I'll be doing the labeling, the training, making sure the model itself is going to meet the needs that I have, if I need to go collect more data, things like that, and then do the code generation. And so I have a model.c, model.h, or whatever I wanted to name it. I'll have those files available, and those files will have everything needed to say, okay, queue the data in, feed data into it, and then the APIs to make a decision to dequeue the data out of the model. So now I have to turn my attention then to the development side, or the embedded development side. So there is a specific Deepcraft Studio deploy model code examples. And these are actually the same code examples that we used on the previous screen where I was talking about the starter models. So it's the same use case here. The models that we have, right, and in this case, I'm highlighting three, just because the radar use case, there's not a starting model for the radar use case right now. But there are three different code examples available inside of the Modus Toolbox Project Creator, one for audio use cases, one for motion, which is the accelerometer, gyroscope, and then one for radar. And these, the way these microphone or sensors are interfaced with, right, the way their data is read from them aligns nicely to the way the streaming protocol works. So there, you'll know that the data that I trained on at this first step is the same way I'm generating the data, right? Reading data from the sensors that I'm feeding to the model inside of this particular code example. These code examples do work out of the box with a default model, but again, I can then go back into Studio with my own custom data, right? My specific use case that centers around data collected from the streaming protocol to be able to generate code for my specific model and be able to drop that into my application. If there was any pre-processing or anything that was done that was utilized inside of the GraphUX, that is generated in code. So now I can deploy that and actually run that as part of that generated code on my device. So this is going to be the primary step for creating a model effectively from scratch as it relates to the PSOC 6 AI kit. Now you can go even further than that, right? So this is leveraging the streaming protocol, which is designed around the onboard sensors, but that can be opened up as well to do a variety of other things. I can create my own sensors, leverage the streaming protocol to feed in custom data into it, and then replicate that on my own deploy project to be able to read that same sensor data and feed it into the generated code. One of the recent releases, so this just happened a few days ago. So we've talked a lot about the streaming protocol as firmware. This is now available as a code example. So you can also download the streaming firmware as a source code library. So you can actually see what's happening there if you did want to modify it or adjust it to make your own sensors, right? To read sensors other than what's on the board. That is possible or enabled through this additional streaming protocol. And again, the flow here, right? Collect the data, get it into Studio, move it into the IDE, and then deploy it back onto the board. Okay, so with that, I mean, that was kind of the general concepts of what we wanted to cover. And I wanted to switch over to a live demonstration now where we can walk through some of the features and capabilities of this tool. So let me close my presentation here. And the first tool that I wanted to go into is that we're going to open up Deepcraft Studio. And I've got basically a new project. I do have some items brought in. I guess my first step is I do need to connect my board. So let me plug my board in. With the board attached, and this board is running the streaming firmware. So in a little bit here, it will refresh, make sure that it is reset. So now it's detected my board. The use case that I have right now is I've brought in the microphone data. When you first open up Studio, if you don't see this particular view, this is the Node Explorer. You can always come up to the view and open up the Node Explorer. It may show up in a different place, but you can move these windows around, redock them, do things like that. Excuse me. Oh, in fact, I just made it floating there. All right, so with this, right, I have a view that I can bring in some different data. Maybe I want to add some additional filtering right there. I actually clicked on the hand smoothing. Maybe I want to bring it in as a spectrogram. You can click on these, get more details about what they do, kind of the value that they bring inside of the properties. And I'm actually going to connect this. Oops. We'll connect this to our audio in. And we will grab an additional data track here. So we'll come back up to our visualization. We'll grab another data track, throw it onto our GraphUX screen here, and we can connect these as well. So now I'm going to have data. It's both microphone data coming from the board, but I've got it actually represented in two different ways. This is just to kind of show, maybe I'm using one for doing my actual model, but this one's helping me to visualize it. We'll quickly save this and we can go over to the view where I'm capturing data. So I've got the board connected now. We'll let it's generating the code and the background details here. I did put this on a small resolution screen so we could more easily see things on the webinar. But of course, that comes at the cost of now I've got to slide windows around. But now you can see, like, as I talk, right, I'm capturing the audio data, but I also have a view here down below where that's being processed through kind of the filtering, right, the spectrogram data that represents that same data. And so through this, right, we can scale these around a little bit, come back and look at this data. And this can be useful, right, to understand, right, am I looking for a particular frequency or does this help me generate the data? And then with that, I can start adding in labels. So with the slide some things around, but I can add a labeling track to say, okay, this is a particular event that I want to detect and what that exists as. So this is kind of the idea of the data collection piece of it, using GraphUX, right, with the streaming. The other things that I've got a couple of the starter projects open just to highlight. So this is kind of a main starter project application. You can see that it comes with a lot of data. I've got one of those data sessions already open here, just so we can see kind of what that data looks like. So here again, this is audio-based data. This is coming from a standard data source, so you can see different words that are being displayed, and you can actually play this and hear various voices recording different names. And so this is what a typical data track data source would look like. For audio here, it's a bunch of keywords that are being used, and then it's gone back through and identified these with particular labels. So this person's saying, wow, happy 5. Once that data is compiled, once we're happy with that, then we go through the process of saying, okay, I want to send that up to the cloud, right? So coming back to the main project file, sorry, I'm jumping around a little bit here. This was the data, we're happy with it, or we think it's a good starting point. There is some pre-processing, and this is useful, again, as a reference, so I can see, for this audio example, what type of filtering was done. So they had a sliding window, Hammond smoothing. They are doing a discrete Fourier transform, right? So these are things to look at to say, hey, maybe I can replicate this as well. This is best practice for doing audio. The training dialog here, this is where I actually go through the process of doing the cloud-based training. So I can first, I've got some models already created, but I can regenerate those. So I have the generate model. This is where I'm using the auto ML feature. So I can say, okay, what type of model? What are kind of the high-level wizard type parameters that I want to specify, right? I want this to be a small model, right? I'm running it on a small device. And, speed's not as important. I really want accuracy at this time. And so you can specify these type of things and generate the models. And now I'll get a new set of models here that I can go kind of look at. I can see what the parameters are for these models. And there are details about this back on the developer portal. So if you're curious on kind of what some of these terms mean, follow through those guides. That'll help provide some background information there. But ultimately, once I'm happy with the data, I'm going to issue a new training job. So I will submit this to the cloud. It does require that you're logged in, but you can submit that. I won't do that right now. In fact, I think I've got one that I kicked off earlier. And you see it's at least one of the jobs is done. Some of the others are still processing, just to kind of give an idea of what is happening. But as these are coming back, I can start to see some of the statistics on them, right? The confusion matrix, and decide if that model is going to work for me. Once I do have a model, right? So this is about the training of the model, and once it's complete, I can download this back to my computer. Here's an example of one of those models that's already completed. And this is where I'm going to then generate the code. So again, I can look through what's going to be generated, both from a preprocessor side. So what filtering is going to be done or is generated in the code, it'll be done on the device. what type of details, right? How was the quality of this particular model that I've selected? And maybe just to show, I guess this is a good point. So I'm looking right now, I'm in the keyword detector, and these data are actually located underneath the models, right? So this is actually, I just have double clicked. Well, this is a different, sorry. This was from the home detection. I noticed because it's baby cry, cough, and water tap. So this is the actual model that I have open right now. Ultimately, I'm going to generate the code for it. Right? So I'm generating this for the Infineon PSOC device, specifically the PSOC 6, and details about the file names, where I want the file to go, and then I can be able to update and build this application. So there are some utilities that the DeepCraft Studio will automatically download to do the optimization for this device. So that'll be part of the process of generating the code example. So at that point, we have code that has been generated for us. We're ready to start doing the embedded side of it. So let me bring up the Modus Toolbox. I've got a couple of code examples that already opened up, a couple of the interesting ones. I do have the streaming protocol code example. So this is available. I can actually compile this, flash it to my board, or as we highlighted earlier, let's switch to the web page. I have there is a tutorial on Hackster.io for updating the firmware. This is that development kit web experience. I have my board connected in a different way, but if I connect it so that it's usable on this, then I'll get a third option here that would able to restore. In fact, we could probably go ahead and do that. Let me just to show what that will look like. Connect it to the debug interface. I'm expecting a button here and I'm not seeing it right now. Oh, let me reset. That's what I need to do. So I had the board plugged in different modes, but we're able to select the board, and this just happens over the connector here, but with that detected properly, right, I have also this DeepCraft Studio. So another option to be able to stream that data or reload that application to do the streaming. So that's the data collection side. If you're using ready models, not needed, but if you're developing your own model, you'll certainly want to take advantage of either the firmware or the project here. If I am working with a ready model, there is a ready model code example. So I have that opened up already. I do want to highlight a few things about this. First is this is one code example that covers both several audio use cases as well as the radar gesture detection. And the way you change that is through the makefile. There's a README here that has all this detail, but I can highlight it real quick. So in the makefile, we'll scroll down a little bit to get to the kind of the configuration section. So here's a model selection. So there is a parameter here, model selection. Right now it's default to siren model, but I can change these, right? So if I want to do the gesture model, I can copy this value, replace this here. And now if I compile this application, program it to the board, this example project is now using the gesture detection. So it's fairly easy to switch between the different use cases to be the one that you want. Now, what's interesting here, though, is I got to go do something with this application, right? Because right now it's going to do a printf. That's not a worthy application, right? We want to do something real with it. So I can point out where we do things with that in the files. So we'll look at the audio.c file. This is, again, where's going to the audio type aspects for this project going to be. In this outline view, I'll use this to jump down. We can see the functions, and this is a FreeRTOS-based application, and there is an audio task. So I'm going to jump to the audio task, and we'll look at some of the details here. So there's a background task. Since this is FreeRTOS, there's a background task that's monitoring or it's collecting data in kind of a ping pong buffer. And once it has a buffer filled, it will set a flag and say, okay, I've got some audio data. Let's go do something with that. And so it walks through that buffer, that array of audio data, There is some normalization that's happening because, right, we want to make sure we've scaled it appropriately so that it matches what this ready model, because we don't have control over changing to the ready model or changing how the data was collected. So we need to align our data to that. So I do some normalization to it, and then I start pumping in data, right, one kind of bit at a time into the enqueue function. Once the enqueue function has enough data, or once the model has received enough data, then we'll get a valid result from our dequeue function. This is where I'm able to take data. I have data out. So again, I got a success that, yes, we were able to run a successful dequeue. We've got information out of it. And I can then use in this case, some checking of the data out. So that's the pointer that was part of the dequeue function. It will contain the results, right? Did I detect a radar? And this one's pretty simple, right? There's only a yes or no type answer. Some of the other ones, and we'll see this in the radar one, where there's more than just a binary yes or no. But in this case, if it's a yes, then we're going to print out something that says, hey, we detected this particular event. And this is where you would then add in other code, right? I don't want to just do a printf. I want to go turn a light on or go do something about the results of this model. But this is where you would then pay attention to the features. On the radar side, kind of a similar implementation. We'll jump down here to the list of tasks. This one actually is in the processing task function. So again, there's some normalization, there's some processing that has to be done to make sure that the data is collected to this kind of generic ready model. But I am going to be doing the same thing. I have an enqueue function, and these are functions that are generated by Deepcraft Studio, where I pass in the data. Once I have sufficient data, then I get a model out. And in this case, right, once we get a success, there's actually a couple of different options. In fact, we'll iterate through those to say, was this a swipe left? Was it a swipe right? Was it a press? And you can check out these. These are all in the generated code of the kind of the array of what the possible detection values are. So for doing a radar-based ready model application, this is going to be the place inside of the code to go pay attention to. Now, that's ready model. So let's then turn our attention a little bit to, if I'm doing the broader stuff, right? I'm generating my own model. So the good one to use here is the deploy model. I've brought in the audio one, but as I mentioned before, there's an audio one, there is a motion one, and then there's a radar one. So 3 different use cases for the types of sensors that are available inside of the streaming firmware and on the PSOC 6 AI kit. So here, a couple of things we note is there is a models subfolder. This is the generated code that came from Deepcraft Studio. So as you generate additional models or your own use cases, this is either the folder location where you want to tell Studio to generate the code into, or if you're just cut and pasting it manually, this is where you would then drag and drop it into this particular folder. The main file here, and the main file will differ based on the use case, right? So this one's going to be exclusively audio. So it's going to have the same audio setup that aligns to the streaming firmware, which is a key thing, right? So we're using a streaming firmware that collects audio data in a specific way, a specific frequency and things. So we want to make sure the models are aligned there. So this code example is a good reference to set it up the same way, or if we did need to tweak that or adjust it for how you're doing it in your model, this is where you would make those adjustments. This is not a free RTOS. This is just a real kind of basic bare metal application. So it's a little bit more of a simple use case. So we get down into the details. We're going to set up our board. We're going to initialize the model itself. This is API that was generated inside the model.c. We're going to initialize the audio. This is what's setting up the digital microphone. And then we just got a big for loop here. So we're going to read some data from the audio, right? Make sure we have a buffer of audio data. And then we're going to work through that data. There is some sampling just to make sure that things they're clipped correctly as we move it from floating point conversions, things like that. But ultimately, right, we are going to be doing an enqueue, right? This is where I'm passing in, a data point at a time. And then down here, I'm doing the dequeue, right? Where the data here is our label score, right? what is the likelihood result in this case of the particular audio event for this model being detected. And I think we can check. I think that this one is doing, oh yeah, this is the key spotter, right? So we can see here, these are the different symbols that this default model comes with. Now, of course, if you were to regenerate your own model, the generated code would have your specific labels in here for your project. Okay, I think those are the main pieces that I wanted to show. So I think with that, we can flip it over to the Q&A. I did see that there is one question that was asked. Someone was saying that I'm making a custom application and I need vibration and sound. Shall I collect both together and label them together, or shall I collect them and label them both differently? So there are two different approaches to this, right? So most of the example applications that we have inside of Modus Toolbox are kind of a single model. So you do one DQ and one output, one NQ, one DQ. But when you go through the code generation process for those, you can generate unique names and unique files for them. So it is possible to have multiple models inside of it. So you're passing data into it. And so those are kind of done as two independent code generation pieces. Now, the other side of that is, what we refer to as sensor fusion. And it's where I'm actually taking the data and I'm feeding it into the system as kind of one combined set of data. Now, there is one, challenge with the way the studio code generation works today is that it really needs the data coming in at the same kind of frequency. So for your use case here, where we're doing vibration and sound, you're probably going to either want to sample the data, right? You're going to need to get the frequency similar. So sometimes that's done through increasing the vibration sampling rate or copying it. But ultimately, you want to have one set of data that's running at the same frequency that can feed into a single model. So that's one use case. Or the other approach is actually running them as two independent models. So they're each making a independent detection. And then you are stitching those detections, right? So if both events are true, then we can go do something with it. So in terms of collecting large amounts of data, so that is a challenge, right? So, Studio itself supports the ability to have lots of data tracks. So you don't have to necessarily collect it all in one big, large data file. You can collect it in a large number of files, whatever works best for how you want to handle your data. So in terms of documentation, right, download guide for DeepCraft Studio, best place is going to be the developer portal. So if I switch back to my presentation real quickly, and I know we're running short on time, but we do have at the end of the presentation that you'll download the PDF version, there is a slide at the very end of it that does show the specific links. And one of those is a link to the portal. Let me see if I can share my, apologize, I'm not getting the sharing to work quite right now, but you'll have access to those. There's PDFs. These presentation will be available as the recording. Again, the question on multiple model.cmodel.h, look at the guides, right? You'll need to make sure that they're named correctly, right? So they'll have to have unique file names as well as unique API prefixes to be able to enable that. Okay, Jocelyn, I think maybe there's a few more questions that might be coming through in the chat.
Yes. Well, and there were a few that were sent ahead of time, particularly around some radar questions, radar detection. If you check, the chat.
Yes, we'll do that now. So some of the details on that, right? I'm not necessarily the person that understands, right, how the radar actually works, right? So what I would recommend, right, is if the streaming protocol itself does do some level of radar collection. Now, you can certainly look at the streaming protocol code example and see exactly how those radar algorithms, how the radar is being collected inside of that source code based application, and look at adapting that for other use cases, whether it's kind of LiDAR mapping or some of the other things that I see inside of the chat window. So kind of the default behavior or the default method of using the radar detection is really with the streaming firmware, which is doing a particular method, right? A particular frequency that data is coming through. So it can be used for a variety of use cases. I think you would just have to look at, kind of do some test cases on collecting data and see if it feels like it's unique enough data or distinction inside of the data that the model actually returns valid results. So try it out, right? See if the stock firmware works. You can train a model and see the results. Like, is it able to detect the correct thing and reject the background noise or reject things that it doesn't need to detect? If it doesn't, right, and it really is, we need to change the way the APIs that are used for how the radar data is being collected itself. That's when you'd have to then turn to that streaming application and figure out the link for or figure out the actual algorithms for how the sensor is being used, and then replicate that both on the deployment side as well. So, but again, I have less familiarity with the technical specifications of radar, but I know there are a lot of details related to radar that are available at Infineon.com. There's a question on which are the models free or what do they pay for? The ready models, if you were to productize an actual application using a ready model, that is a licensed cost to be able to use it in an end application. But what we're leveraging for the design contest and kind of this prototyping are evaluation versions. So those are freely available. They are time limited, or they run a number of inferences before they time out. So that would be the limitation, but it's certainly enough time to be able to kind of prove a concept, something to understand how something works. For data that you're collecting yourself, right? You're generating your own model. That, of course, is entirely your IP. There is a number of credit hours that you get for using the cloud processing. It should be entirely sufficient for most of the use cases we're talking about. But if you did exceed that, then reach out to Infineon, to Magimob, in terms of either getting some additional credits reset, or if it is kind of going into a production type environment, a cost for any additional hours or credits for doing additional training. But you get a pretty good amount that should cover a couple of different prototyping use cases. All right, let's look through this, right? The cough model can be used to specify type of cough. So the model as it exists today is really just detecting cough or not cough. It has been trained, I will say it has been trained specifically on very heavy, more serious coughs. So that is what it's designed around. And detects. It doesn't necessarily give you any type of a data point to say this is a normal cough versus a more serious cough. That's not the data and the training that was used to do that model. But that's a great use case of saying, hey, I could create my own model and actually label the different types of coughs, right? This is a standard cough. This is a serious cough. So that's a good use case that can be used with the data. The ready model as it is, though, is just kind of, yes, a cough, no, not a cough, but was trained on more heavy coughs, right? It has to be a real deep cough. Let's see, looking through the list to see if there's any other questions that I missed. There is a terminal program. So someone asked if I had a connection to the computer. So if I am running one of the models, I don't have it programmed right now, but yes, most of the models, in addition to doing the detection, will do a printf. And that is done through the debug interface through the UART. So you connect a Teraterm PuTTY type application. Details are in the README files for the code examples on the baud rate and the things to set up